All right, hyperbolas, let's do it. One more section after this, but we're not having the test for a while because we've got Memorial Day coming up and then some review. So I will try and post dates and stuff probably tomorrow. Today's Monday. No, goodness gracious. Today's Tuesday. So I'll try and get that stuff posted for you. But take a minute and copy all this down. Pause me. Okay, so some things to point out. Again, the green C indicating a length is the lowercase, and then the C here represents the center. The center is HK, just like it was for the vertex of a parabola and the center of an ellipse. These are asymptotes. We'll talk a lot about those when we do a problem. The foci, again, just like the ellipse, are inside of the hyperbola. It just kind of means something different in this case. Inside means further away from the center than the vertex, whereas with the ellipse, they were closer to the center. We only, for purposes of graphing the actual curve, we're only focusing, or maybe I should say graphing the vertices, we're only focusing on either the r sub x or the r sub y. We don't need both for the vertices. We need both, though, for the slope of the asymptote. So I don't want to keep this abstract. Let's do some problems. But one thing to note is there are two different ways that this looks. This is almost exactly the same as the ellipse equation, except it's got a minus in between. The positive term goes in front, and that tells you which is the transverse axis, or which direction the little, they're not actual parabolas, but they look like parabolas, which direction those open. So in this case, the y the y is positive, so it opens along the y-axis, okay? And then this is almost exactly the same as ellipse as well, but instead of a minus in between the a squared and the b squared, it's a plus. So it is exactly the same as the Pythagorean theorem. Okay, so hopefully this example will help you on, if you were stuck on some of the ellipse problems like this, hopefully this will help you. So I always start out by drawing a picture. I have to graph it anyways, so I might as well give myself that visual. So let's see, I have to go up pretty high. No, I have to go right a fair amount and down. So I'm going to focus my graph on that and then see where I go. 1, 2, 3, 4, 5, 6, 7. Hopefully I have enough space. I did not do this ahead of time. Yeah, I think we're going to be good. Oh, that's not the right one. Yeah, we're going to be good. Okay. So the center is at 4, -1. 1, 2, 3, 4, -1. I'm going to label that. There's one foci at 7, one focus at 7, -1, and there's one vertex at 6, -1. So I need to use my drawings up here to figure out what I'm being given. The distance from, so now I can tell that this is going to be a horizontal transverse axis because the center, the vertices, the vertex, and the focus are all lined up horizontally, not vertically. So you can see center, vertex, focus all lined up horizontally. Here they're all lined up. Oh, I didn't label the center on this one. Here they're all labeled lined up vertically. So I know it's going to be this case, not this case. And I can see that the distance between the center and the vertex is the r sub x. So in this case, the r sub x is 2. And then I can see that the distance from the center to the focus is the c value. So from the center to the focus is the c value. That is 1, 2, 3, right? Now I can mirror these in the other direction. There's 2 away from center to vertex, so the other vertex is going to be over here, and then 3 away from the center to the focus, so the other focus is going to be there. Now I can't draw anything else after this because I need to know the slope of the asymptotes, and in order to find the slope of the asymptotes, I need the r sub y. You can see it up here. I need the r sub y. So I'm going to use this equation right here. I know the C is 3. And then now, I don't know which one's larger. I don't know if the r sub x and the r sub y, what the relationship between the two of them are, but it doesn't matter in this case because it's a plus. So I can put them in either spot that I want to. If you want to be consistent, when you do know, put the larger one in the A. But I don't know at this point, so I'm going to do that. And then this is what, 9 subtracting the 4 over, right? 9 minus 4. So then B is going to be plus or minus rad 5. So that tells me the r sub the r sub y. Whatever's remaining, okay, is the r sub y. So this didn't come out to a nice number, but we can make it work. It's fine. From here, I'm going to switch colors. Hold on. From here, I'm going to say the slope is plus or minus ry over rx. So the positive slope, right, going up from left to right, and the negative slope going down from left to right, positive, negative, okay. The ry is rad 5 over the rx is 2, and I can estimate that because rad 5 is slightly larger than rad 4, right? So that means rad 5 is slightly larger than 2. So this is just a little bit larger than 1. I mean, I could put 1.1, oops, 2.1 over 2, and then this would be 1.05 if I wanted to do that. So rad 5 is slightly larger than 2. Divided by 2 gives me something slightly larger than 1. Okay? So then when I'm plotting the slope, that's really obnoxious. When I'm plotting the slope, I'm going to always start from the center, just like I said in the last video. And I'm going to plot a slope of approximately 1. So I'm just going to go up 1 over 1, up 1 over 1. Yeah? Because it's so close. Up 1 over 1. If I was doing this on graph paper, it would be much nicer. Down 1 over 1. So there's my positive slope. Down and left or up and right. And then my negative slope is going to be the other direction. Up and left or down and right. So I'm going to do something like this-ish. It's not going to be perfection. Okay. And then from there, the way that I draw the actual kind of parabolic shaped curves is I start at the vertex and I just approach the asymptotes. Just approach the asymptotes. Okay. Good. So for this one, I want you to give me the other vertex. The other vertex is what? 2, -1. The other focus is 1, -1. There's not another center. There's only one center. I also want the equation, oops, that's what I forgot up here. I knew I was forgetting something. The equation of the asymptotes. Oops. Okay, so pause me for a second, write that down. Another thing I want to point out, which I pointed out with the parabolas and it wasn't really relevant with the ellipses, is that the x coordinate of the center, the h, is always connected with the x in the equation, and the y coordinate of the center, k, is always connected with the y in the equation. So even when they switch order, the y coordinate is connected with the y and the x coordinate is connected with the x. And even in the equation for the asymptotes, the y coordinate is connected with the y and the x coordinate is connected with the x. Okay? So let's write that equation. This is just point slope form, by the way, you guys. Y minus y1 equals m times x minus x1. Don't overcomplicate that. It's just point slope form. So I'm going to go y minus the y, where's the center? The y coordinate of the center equals the slope times x minus the x coordinate of the center. Okay? So this is the equation for the asymptotes. And the equation of the ellipse itself. I would like that also. So again, we're using this one up here because it was a horizontal transverse axis. So I'm going to go x minus h, y minus k, and then under the x goes the r sub x squared. Under the x goes the r sub x squared. And under the y goes, where'd it go? Goes the r sub y squared. Okay? Okay, so I hope that that helps you with the hyperbola, the ellipse stuff from last time. Let's do one more though. Obviously the directions in the book are not going to say find all the stuff. I just don't feel like writing it all out and then writing it all out in the answer again. So we get to practice completing the square again. Woohoo! I know you're all cheering about that. Yay! Okay. I'm going to group, and I'm also going to factor out that negative. This is the place where people make the mistake on this. You could be completing the square pro and still make the mistake on that. So I put the x squared with the x term, and I put the y, excuse me, the y squared with the y term. My allergies are so bad. My throat is super dry. I factored a negative out from both of the y terms, so that became a plus. I left myself a space so I could complete the square. So I'm going to divide by 2 and square it. I left myself a space so I can complete the square. I'm going to divide by 2 and square it, right? And then I have to do the same thing to both sides. So I'm going to go like this for this one. Now this one is really a -1. This is the only tricky part, and it's kind of hard to wrap your head around. But think about if I simplified this, I would have x squared minus 2x plus 1 minus y squared minus 2y minus 1. So anytime there's something in front that's being multiplied to what you completed the square, you need to multiply that times that. Whether it be just a -1 or a number, a different number, okay? And then again, just like before, the whole purpose of completing the square is to have a perfect square. So if you don't end up with a perfect square, then you did something wrong. So this one is going to be a plus. And then just like we had last time, something cancels out nicely. And there's no need to divide at this point. I could write these over 1 so that it's easier for me to see what the r sub x and the r sub y is if you want. So first I'm going to find the center. That's the h comma k, so this is 1, -1. The r sub x and the r sub y, this is r sub x squared and this is r sub y squared. Remember, it's always equal to 1 for hyperbola and ellipse. Okay, and then I'm going to start drawing. So right and down is my center. And I need to know which one is the transverse axis. So take a second and look at the previous page of notes and figure out which is the transverse axis, or the, yes, the transverse axis is what I'm trying to say. So X is the transverse, which means it is horizontal. So the r sub x is going to tell me the distance from the center to the vertices. The positive term, right? So we have the positive x, horizontal transverse axis, links me directly to r sub x. So we're kind of working our way backwards through this information. We're comparing the equations. We see it's this one and not this one. So that tells us that it's a horizontal transverse, and that tells us we need to go left and right to find the vertices. Sorry, I don't know why it's like being blurry when I put my hand in here now. Maybe it's always been doing that and I just never noticed it. Up and down to find the vertices if it looked like this, but it doesn't, okay? So that means I'm going to use the r sub x, although I guess it doesn't matter, but they're both 1.